This video is about the isotopes, part 1, where we are going to talk about how to determine number of particles for isotopes. It is basically same the way you did for other elements. It's not different, very different, except how they are represented, and there are two ways to represent isotopes, all right? And what is the definition of isotopes? So it's not very different to figure out number of protons, neutrons, and electrons from what you have done earlier. Here are three subatomic particles of an atom: protons, neutrons, and electrons. The charge on proton is positive, abbreviation P plus. Location, it is protons and neutrons, they both are located inside the nucleus. This is their mass, 1 AMU. Neutrons have no charge, electrons are negatively charged, and they are located outside the nucleus. When we talk about the mass number, we do not include electrons just because they have negligible mass. Okay, so just wanted to go over with that. And as I said, determining number of protons, electrons, and neutrons, we are still following the same algebraic expression where A is equals to Z plus N, and to find neutrons, A minus Z. This is the same one that we have followed before. Now the letter A represents the mass number, and letter Z represents atomic number, which is also equals to number of protons, and is your neutrons. So atomic number, when you have to find the atomic number, you look at the periodic table, and if you ever get confused between which one is atomic number or mass number, whichever is the bigger number is your mass number. It is equals to number of protons. And protons are always equals to number of electrons when we are talking about neutral atoms, which we are. On the periodic table, we see neutral atoms. So number of protons and electrons are equal. And even for today's lesson, the number of protons and electrons are equal. Neutrons is, as we said, A minus Z, and our A is mass number. So A is mass number, and the Z is atomic number, so minus atomic number, or you can say mass number minus protons. Either one is okay. There's the same thing. All right. There you go. These are the algebraic expressions. This is how you find atomic number. To find atomic number equals to number of protons. You look at the periodic table for atomic number, protons and electrons are equal. And for neutrons, you subtract atomic number from the mass number. So what are isotopes? Because our focus is on isotopes, that's our main topic. These are the different atoms of the same element. This is important to understand that they are the atoms of the same element, or you can say different version of the same element. Of the same element. They have the same number of protons, so with the same number of protons. Letter P stands for protons. So same number of protons, or I can write the full way. Meaning, if it is same number of protons, that means same atomic number. Because atomic number is determined by the number of protons. But with different, what is different about them is different number of neutrons. Okay, so because of the different number of neutrons, what else is different is the mass number. Different mass number. Okay, so isotopes, they are the atoms of the same element. They have the same number of protons, meaning they have same atomic number, but they have different number of neutrons. As a result, they have different mass number. So let's take any element. We can take oxygen. All right, oxygen. Isotopes of oxygen, oxygen 16, oxygen 17. So on periodic table, you're going to see only oxygen 16, and the atomic number is 8. Atomic number remains same. So this is the way you represent them, and let's check if it makes sense. Does it match with our definition? So we said that atoms of the same element. Well, these are two. You can see this is oxygen and oxygen, so it's the same element, right? Just a different version of oxygen. On the periodic table, you see only 16, you don't see 17. Well, that's a different reason, but let's focus on this first. Is it representing isotope or not? So this is correct. They have different mass number, right? Mass number is different. And this one is correct as well. Same number of protons, which is at the bottom. So at the top, you have mass number. At the bottom, you have atomic number, which is actually number of protons. So I was telling you on periodic table, you see only 16, oxygen 16. The reason for that is the most prevalent. So in nature, we have different versions, different isotopes of oxygen, but we cannot put all of them on periodic table. So what you see is the weighted average of all those isotopes. And that is the reason you have those numbers in decimals. Otherwise, it's how are we going to talk about fractions of an atom? Atom is very, very small, right? So they are not the whole number because it's a weighted average, and that is based on the abundance of the isotopes. So whichever is the most abundant is the one that you are going to find on the periodic table. So once again, why do you see oxygen 16 on periodic table? Because oxygen 16 is the most prevalent isotope out of all other isotopes. And why is this number not a whole number on periodic table? That's because that is a weighted average. So I'm going to write it here. Instead of 16, you see 15.9, right? And not 16. What is the reason? That's because it's not a whole number, because it's a weighted. I have to tell you, it's a weighted average. All right, this is not the simple average, it's a weighted average. This is like, how you do your grading. Test counts the most. 30 per test is 40%, other performance is 30%, your classwork is 20%, homework is 10%. So it is all weighted. So this is weighted average, and the reason being because not all isotopes in nature are present in same amount. Okay, that is why the one whichever is the most prevalent is the one you are going to see on periodic table, and that is the reason you see the decimals and not the whole number. There are two ways to represent isotopes. Two ways to represent isotopes. One way is you write the symbol and you write the mass number at the top. So I'm taking example of carbon, or you write the full name and then hyphen, and then you write down the mass number. So this is one way and this is another way. Two ways to represent isotopes. Again, you write the symbol and mass number at the top. What you need to remember all the time is that this number at the top is the mass number. What you need to remember here, this number on the right side of the name of an element is mass number. Okay, that's not atomic number. So these are the two ways to represent isotopes. Now let's work on actual problem. Let's say you have isotope of boron, and this information is given to you already. So if this information is given, you know that the top number, this one is the mass number, protons plus neutrons, and you know that this number is atomic number, which is actually number of protons. So the protons here is 35 because that's the atomic number. Same number of electrons because it's electrically neutral, and to find neutrons you are going to subtract both these numbers, mass number and atomic number. You're subtracting atomic number from mass number and you get 45. Alright, that is how so this was straightforward. You didn't even need your periodic table to do this, as the atomic number was already given to you. So these are the problems that usually asked in the test. Okay. Now you should try the next one this time. Let's see. Okay, let's work on this one. Phosphorus 31 and 15. Zinc 65 and 30. Both these elements. Again, you do not need periodic table because atomic number is given and the mass number is already given. So if this is what you got, you have it. 15 is the number of protons, which is atomic number, electrons same, and neutrons, you subtracted both of them. And this is another way to write down, to represent isotope, is phosphorus 31. Here is the mass number, and for this one is zinc 65, the mass number. Protons, electrons same, and for neutrons you subtracted top and bottom. Alright, how about, let's do this one. Oxygen 16 and 17. So if you have to figure out number of protons and electrons in this problem, you will need your periodic table. Why do we need a periodic table? Because atomic number is not given. Unless you know it, then it is okay. If you don't know it, you need periodic table. Alright. So for this one, atomic number is 8. How did I figure this out? I looked at the periodic table. Same atomic number 8, and atomic number, protons and electrons will be same. Now what is different is the number of neutrons. So because the atomic number is 8, which is same, look at the top number, which is different, and it is the mass number. So because of the different mass number, that shows that number of neutrons are different as well. So you're doing here 16 and atomic number is 8. Here 17 because that's the mass number, minus 8. So here you get 8, here you're getting 9. See that? This is different. But rest of this 8, 8, 8, 8, 8, 8. All same. But this number of neutrons is different. Even though they are same element. Okay? They are just the two different versions of the same element. But still their number of neutrons are different because they are isotopes. Right? Okay, one more. How about helium-3 and helium-4? This one, helium-3 and helium-4. When you look at your periodic table, you're not going to see helium-3. You're going to see only helium-4. Remember, because what you see on periodic table is only the one which is most abundant in nature. So helium-4 is more abundant than helium-3. And you need periodic table to know its atomic number. And atomic number of helium is 2. So is the number of protons. So protons will remain same. And so is the number of electrons. And the neutrons will be mass number minus protons, or you can say mass number minus atomic number, which is this one here. And for this one, 4 minus 2, 4 minus 2, this one 3 minus 2, and you get 2 here. Okay, So number of neutrons is different, but number of protons same, electrons same. And once again, when you represent it, this is helium. So they both are helium. This is helium-3. This one, helium-4. Now you try this. Pause the video. For chlorine 35 and 37, just remember that 35 and 37, they are the mass numbers, not the atomic number. Again, you're not going to find both the isotopes on periodic table. Whichever is more prevalent is the one is going to be on periodic table. So out of all those isotopes, if this is what you got, that means you got it. Mass number 35 from here, 37 from here. Atomic number 17 and 17 that I'm getting from the periodic table. Atomic number, protons and electrons, they're all same. Neutrons is the one which is different. So 35 minus 17, you get 18. 37 minus 17, this 17 or that 17, you get 20. And this is another way to represent them. Let's do one more thing before I wind up. Here, these are the pairs, but we need to figure out which one of them is actually representing isotopes of the same element. So first one, this one is incorrect. And why is it incorrect? Look here, these mass number at the top are different, and which is perfect because you remember by definition it says for isotopes the mass number is different, but their atomic number is differing as well. So they are not the isotopes of same element, because if the atomic number is different, that means they are the different elements. Number of protons are different, that means they are different elements. Okay, now here second one is you have same mass number. So this is incorrect. Why is this incorrect? Because our definition says mass number or number of neutrons differ for isotopes. All right, and again if you look at the bottom, completely incorrect because atomic number has to be same for isotopes. Here this one 12 and 14, which makes sense because they are different mass numbers. Also at the bottom it is same atomic number. So this is the one which is correct. So this goes with our definition of isotopes, this one. Neither that nor this, only this one. All right. Sometimes you may be asked to tell the name of elements. So you are given two isotopes. Isotope 1, and isotope 2. But you don't know what are these isotopes. All right. You are given protons and neutrons. So you have 12 protons and you have 13 neutrons for this isotope. And for this one, you have 12 protons and 14 neutrons. Now your job is to identify what element is it. Now you remember guys, what have we learned earlier? That number of protons determine the type of element, what element it is. So what are you going to do? You are going to look at the periodic table and you are going to look for number 12, which is atomic number. So you look for atomic number on the periodic table. Okay, so in order to tell which element is it, what's the element here? This is what you are going to do. You are going to look at the number of protons because you go by number of protons. They are the same here. So we have definitely know it's the same element. And when you look at it, this element is actually magnesium. Okay, so it is magnesium 25, because 12 plus 13 protons plus neutrons gives you the mass number. And this one, when you add it, it is magnesium 26. Now you might say, Miss, but there is no 25 and 26. You are right. Yes, there is no 25 and 26 on periodic table. However, it is there in real, in nature. Okay, because what you see on the periodic table is the one which is most abundant. You do not have magnesium 25 or magnesium 26 on periodic table, but still this element is magnesium because of the number of protons. All right, so on periodic table what you see is magnesium 24. That is on periodic table. All right, but here protons plus neutrons 25, protons plus neutrons is 26. Since the proton is 12, atomic number is 12, you can tell this is magnesium. Alright, so last one here. Pause the video here and see if you can do this. Here I have given the element, like for hydrogen, 3 isotopes. Hydrogen 1, hydrogen 2, hydrogen 3. It's protium, deuterium, tritium. Right, so mass number different. Again, on periodic table you see only hydrogen 1 because that is the most prevalent, most abundant in nature. And this is how you represent. One way is to represent hydrogen, hyphen and 1. Another way to represent is you put a symbol, mass at the top, atomic number at the bottom. So these are the mass numbers you see, and here you have an isotope of carbon. So these are the 2 isotopes of carbon, carbon 12 and carbon 14, and you're going to fill out the rest of the information. Check here please. If this is what you got and it is correct, that means you got it. Alright, thank you for watching.